Now in this question is having two processes, computer and science. Okay, is having some simple processes defined with the name computer and science. And next he is using three semaphore variables. So semaphore mutex, q and r initialized to 1. Okay, all are initialized to 1. Okay, so I'm writing here mutex m and q and r, all are initialized to 1. And next he is asking, okay, which one of the following above, okay, which one of the following holds okay by the above process. He's asking deadlock and no starvation. Okay, deadlock, no starvation. Okay, he has given various statements. Okay, right answer is straight away C, both deadlock and starvation. So first of all, okay, both deadlock and starvation may not be like no need to think about it, because if the deadlock exists, definitely there exists a starvation. So we can clearly say upper bound deadlock exists. So deadlock exists, obviously starvation exists. Deadlock includes starvation. So okay, how deadlock is possible? Let's try to start. So first I am starting with the computer process. Observe carefully. I am starting with computer first. Okay, first you say down of mutex. Okay, it becomes 0, and now you say down of q here. When you say down of q, q becomes 0. Now after this, let's say assume that I am just taking the preemption here. Now I'm starting with the okay science process. So I use a different marker. So let's say okay science process. When you say p of q here, p of q, now q value is already 0. So what happens? This will be suspended here. And next after that this preempted process is coming back. Now preemption is just a temporary stop. Temporarily, maybe because the time quantum expired, it got preempted. So when the process p is coming back, okay, it will perform what? P of r. When you say down of r, r value also becomes 0. And next, let's say after that it is saying up of q. When you say up of q, okay, on the q, okay, it is already in the suspended list here. So what happens now? Okay, it will start a wake up. So when this is wake upping, okay, now look at here. When this is wake upping, it will execute the next statement. It will execute the next statement. When it is executing the next statement, what happens here? You say down of r again. When you say down of r, r is also 0. Again, it is suspending here. And next after this, let's say this is executing next statement, up of mutex. When you say up of mutex, mutex value becomes 0 to 1. But next, okay, if you say up of mutex, after that, you say again down of q. When you say down of q, q is already 0. Okay, because q values are still 0 only. It is not modified. So when you say down of q here, now here this process also gets getting suspended. So this is suspended here, and this is suspended here. Then both are suspended, and that leads to deadlock. So nobody is able to continue the execution further now, and there is no other process to wake up them, and that leads to deadlock. So the simple solution, okay, you should get an idea. Okay, let's say it is getting preempted here, and after that this suspended here, and you say down of r, and when you say up of q here, okay, this process is wake upping, but it's again suspending here. Okay, process getting wake up here, and it will execute this statement. This r was already 0. Now it will say down of r, it will suspend here. Now when it's coming back, again this process will say up of q, okay, and again up of mutex, and next will say down of q. Q is already 0 only. Okay, q is already 0 only. Okay, now when you say down of q, this will also get suspended here. So this is suspending here and this suspending here. Both are suspended, and that leads to deadlock. So right answer is deadlock. C is the correct answer.